Hello and welcome to the sixth tutorial on Python programming. In last tutorial we covered binary number system. Now in this tutorial we are going to cover Boolean operations. The doing of Boolean operations requires knowledge of binary numbers, so I recommend you to go through the previous two tutorials on binary numbers and then come to this if you have not done so. And I always recommend you to do the exercise, that is the assignment that I allot to you before jumping to the next tutorial. Let's start Boolean operations. So first is AND operation. So what is AND? So this operation requires two variables. So variable A and variable B, for example. And these are the possible set of values of variable A and variable B, right? So this can have two values, true or false. This can have two values, true or false. In combination, they can have four combination of values. And this expression variable A and variable B is the expression which we are studying, AND operation. So AND operation is applied on variable A and variable B, and the fundamental here about AND operation is it returns true only when both the operands are true. That is, variable A and variable B have to be true for this whole expression to be true. So as we see from the example, here's false and false returns false, false and true returns false, true and false returns false, true and true returns true. Why? Because both the operands are true here. So for this whole expression to be true, both the operands have to be true. If any of the operands is not true, that is false, the whole expression becomes false. So as you see in the middle two examples, here variable A is false, so this whole expression is false. Here variable A is true but variable B is false, so this whole expression is false. This is true only when both the operands are true. Now let's switch to command prompt for practicals. Although I haven't gone into the integrated development environments which you can use, I mean like Jupyter or Spider or PyCharm or ideally which comes with Python, which will already be there if you install it the way I have shown to you in my first tutorial. So you'll also have these IDEs. IDEs stand for integrated development environment. However, I prefer using this for tutorial purpose. I mean, we'll go to the IDE once we come to development exercises. But since we are only learning the basics of Python for now, I think this is a good way to learn. I mean, explore, and then when you switch to development, then we'll go to IDE. Now, what we are studying? We are studying AND operation. So, AND operation returns true only when both the operands are true, right? So, the symbol for AND operation is this ampersand AND. So false and false. I would like you to guess each of the time what will be the output before I hit enter. So I'm going to hit enter. It is false. False and true. What's the output? Guess the output. It's false. True and false. Guess the output. False. True and true. Guess the output. True. So as I already told you, this operation and operation returns true only when both the operands are true. So as you see here the case. Now let's switch to OR operation. So the fundamental about OR operation is that this whole expression variable A or variable B returns true when any of the operands is true. It does not require that both the operands should be true, like AND operation. Only when both the operands are false, it will return false. So as we see here, false or false is false. False or true is true. True or false is true. True or true again is true. Okay. So let's switch to command prompt. Yeah. False. Symbol for OR operation is this pipe symbol. So false or false. Guess the output. False. False or true is, guess the output. True. True or false is true. True or true is true. So we have covered AND operation, we have covered OR operation. So as you see here, OR operations returns true when any of the operands is true. It returns false only when both the operands are false. As you see here, false or false returns false. Else, otherwise it returns true only. Okay, so let's switch to XOR operation. XOR operation is an interesting operation. So interesting in the sense, it's not like AND or OR operations. So XOR operations returns true only when the operands at both the sides are different. It returns false when both the operands are same. So if both the operands are false, it will return false. If both the operands are true, it will return false. Why? Because both the cases the operands are same. Only when both the operands are different, that is one is true, other is false, or this is false, the other is true, only then it returns true. So as we see here, example, false XOR false returns false, both the operands are same. False XOR true, both the operands are different, it returns true. True XOR false, both the operands are different, it returns true. True XOR true, both the operands are same, it returns false. So it returns true only when both the operands are different, else it returns false. So let's switch to command prompt now. So symbol for OR operation is this operation, hat or cap or whatever you call it. So false XOR false, guess the output, it's false. True XOR false, guess the output, it's true. False XOR true, guess the output, it's true. And then true XOR true. So true XOR true, what should be the output? It is false. Why so? Because both the operands are same here. So this is these are the things, basic operations, Boolean operations. There are other operations as well, so let's switch to them. So before coming to other Boolean operations, I would like you to have a little bit idea of this right shift and left shift. This expression means shift the number 16 to the right 2 times. So 16 in binary can be written as this. Shifting it first will shift 1 here, and the second shift will 1 will be here, and this is 4. 16 right shift 2 times. So 16 in binary, shifting it to 2 times to the right. So as this symbol points to the right, so and 2 means shift to 2 by 2 bits, not 2 times actually. Technically it's 2 bits. Shift this number 16 by 2 bits. So this should return 4 as we saw. If I shift it by 3 bits, it should return, what should it return? I would like you to guess here. So 16 shifted to the right 3 times should return. So how it happens? So this will be shifted to the right again by 1 bit. So this 10 will be 2. So the answer should be 2. And 16 right shifted 4 times should return what? If you're right, it should return 1. Let's see what it returns. 1. So this is how right shift happens. Now let's come to left shift operation. So left shift operation. So this is 16, and this expression means shift the number 16 to the left by 2 bits. So here, when shifted by 1 bit, it will come here. Shifted another bit, 1 will come here. So as you see here, 1 is shifted, and this whole number gets shifted to the left by 2 bits. So it is 64. Let's see the output. So if I shift 16 to the left 2 times, I should get 64, and as we expected here. Uh, what should be the output if I only shift by 1 bit? Let's see, 16 shift by 1 bit. This should return what? 1 will come here, here it will be 0, so it will return 32. Let's see. Yes, it returns 32. If you shift 16 by 3 bits, what should it return? Let's see if you guessed it right or not. It returns 128. So this is binary right shift and left shift. Now an exercise for you is to do 11 shifting 11 by 2 bits to the right. what should be the output. I don't want you to just do this in Python and tell me the answer. I would like you to write the number 11 in binary, shift it to 2 bits to the shift it by 2 bits to the right, and then convert that binary to the decimal number system, and then um, come up with an answer. I am going to show you the answer. So here, pause the video if you haven't done so. The answer will be like this. So this was something which was interesting. So intentionally wanted you to think over this, what should happen. So here what happens is 11 can be written in binary like this, and when you shift it to the right by 2 bits, it is shifted by 2 bits, and those which go off these, I mean there are no bits here, so these two will be ignored. These two digits which are shifted by 2 bits to the right, and which cannot be accommodated in this will be ignored, and zeros will be appended here. So the output will be 2, right? So let's see what's the output that we get. 11 right shift by 2 bits. So this is an exercise on right shift. I have only shown you the 8 bits. However, the numbers are stored in even larger um, byte size. I mean, 8 bits means 1 byte. The numbers could be stored in larger memory size. So when you shift it, these numbers to the left, it will not be the case like these digits are ignored. It will definitely be the case once the size of that, in which size of the memory in which the number is showed exceeds. So let's see what happens when you shift 27 to the left by 2 bits. Just come up, do the same exercise. Write 27 in binary, left shift it by 2 bits, convert that binary number into decimal number, and have the output ready. Try that in Python and see if your result matches with what you with your solution or not. And whatever be the case, let's see what's the answer. Pause the video here. So 27 can be written as this: 11011. Now when you shift 27 by 2 bits to the left, it becomes like this, and when you convert this number to decimal number system, this will be 108. So let's see, 27 left shift by 2 bits, it returns 108. So this is on left shift and right shift. Let's come to comparisons. So these are all Boolean operations. So when you so first operation is equal to. So this is an equality check. When you do single equal to is an assignment, but when you use this symbol double equal to, it's an equality check. So 5 double equal to 5 doesn't means that I'm assigning this to this. I'm just checking, are these two numbers equal or not. So this, since these two numbers are equal, this will return true. However, if I do 5 double equal to 4, it should return false. Why? Because 5 is not equal to 4. So let's see, if I do 5 double equal to 5, it should return true because 5 indeed is equal to 5. However, if I do 5 double equal to 4, should it return true? No, it should return false because 5 is not equal to 4. So this is not an assignment operator. For example, let me show you it this way. Let's assign uh, 11 to A and 11 to B, 12 to C. Yep. So A double equal to B should return true. A double equal to C should return false. And since C is 12, C is not assigned to A. It's not like A will become 12. This is a comparison check. This is an equality check. This is not an assignment operation. This is an equality check. So A double equal to C checks that if A is equal to C or not. If they are equal, this returns true, else it returns false. So since they are not equal, it will return false. Again, if you do C double equal to B, what should be the output? Guess the output and see. That's false. So we'll check the value that A. You see that A is still 11. I did A double equal to C. This is not an assignment. Again, if I check value of C, C is also 12. If I did C double equal to B, B is not assigned to C. It was just an equality check. So equal to operation is done. Now let's come to not equal to. Not equal to, you can check if, sorry, if your both the operands are not equal, then it will return true. So for example, 5 not equal to 5, this statement is false, so it will return false. It will return true when the both operands are actually not equal to each other. So here, as we see, um, a is 11, b is 11. So a not equal to b, it returns false. Why? Because a is equal to b. We are checking for not equal to. Is a not equal to b? No. So that's why it's false. If I do a not equal to c, is a not equal to c? Yes. So it returns true. So this is how not equal to works. Now let's come to greater than. 5 greater than 5 returns what? False, because 5 is equal to 5. 5 is not greater than 5. So let's see. If I do a, let's switch to number 7 variables. If I do 11 greater than 12, what should it return? Is 11 greater than 12? No, it should return false. If I do 12 greater than 11, is 12 greater than 11? Yes, so it should return true. If I do 11 greater than 11, so is 11 greater than 11? No, they are equal, so it should return false. Okay, so this is how greater than works. Now let's come to greater than or equal to. So is 5 greater than equal than or equal to 5? Yes, it is actually equal to 5, so it's checking both. Is if it is greater or equal than this, then it returns true. So yes, here it returns true. So let's see. 5 greater than equal to 5 returns true. If I do 4 greater than equal to 5, is 4 greater than 5? No. Is 4 equal to 5? No. So it should return false. 6 greater than equal to 5. Is 6 greater than 5? Yes. 6 is greater than or equal to 5. So it should return true. Right? So I hope you got the basic understanding, and I hope that explanation on these two, less than or less than equal to, is not required. I would like you to try this on your own. So let's come to assignment. So first assignment is right shift and left shift. So do this on pen and paper, and I will not recommend you to do this directly in Python, because Python will give you the output. I would like you to expect the output first before Python returns anything. And then do this left shift also, shifting 108 by 2 bits, and keep doing the experiment, shifting it by 3 bits, 5 bits, etc. And then second part of assignment is, this is the first part, right shift and left shift. The second part of assignment is, I would like you to do this for these following operations: and operation, or operation, and XOR operation. I have shown you what these expressions will return when you have Boolean operands, but what these expressions will return when you have numerical operands. I would like you to come up with an explanation that why it returns, and you should be able to expect that why it returns. If you are not able to do so, then I'll cover this thing, not the upper part but the second part of the assignment, in my next tutorial. But I would definitely recommend you to come up with an explanation if possible. At least just try. Okay, so thanks for watching. I hope you enjoyed this lecture.